Good day, guys. Like I said, I would put those new components into No Ears and we'll see what difference that it makes. Now at the moment it's 2:20 in the afternoon and we should have a lot of external interference and so forth. And I've got this detector here. You can probably hear it quite easily. I've got the preamplifier, should I say amplifier, clocked up maximum. I had a little bit more to go, so that's absolutely maximum. And I've got the threshold probably at about the right position, so you can get an idea of the noise level that is coming in. And the interesting thing is that the detector front end gain is full. It's absolutely flat out. Now listen, compared to the last video, the detectors are all screaming and carrying on. This is extremely quiet for running full gain inside the house. And just to give you an idea of the improvements over noise and signal, and I have discovered that the camera does make noise as well, because I turned it off and on and listened carefully, and it does make some of these variable noises coming through. And I've also got the back fluoro, the front fluoro on, power supply and soldering station, but we'll have to put up with that. And also I've probably got this big aluminium tripod a little bit close, and also I've noticed that needs adjusting, so I was on a bit of an angle there, so I'll crank that down. We'll go around to where the coil is. And remember, the noise was causing so much issue that we couldn't hear the smallest target. I've got these in, I'll put them in my fingers so they stay there. I've got these ones, the 1 mil by 0.2, the 2 mil by 0.2, and the 3 mil by 0.2 of a millimeter. Now notice when I put my hand in front of the camera, then the noise came up. So there's a lot of funny issues going on with noise in the environment. But at the moment, I've got this detector. It's in normal mode, and I'm going to use a little tiny one. Well, I can tell that even with that background noise on that tiny little 1 millimeter long by 0.2 of a millimeter speck of whatever it is, it's copper actually, it's giving off a very, very decent signal on that full 11-inch double D. Now I've got this detector going, it's full. I've got the variable gain full on the detector. Now we'll go and use that little 2 millimeter long one. Like I say, this is in normal mode. Normally you would not use normal mode to get such tiny, tiny gold. It's bouncing in the noise a little bit now, but something that small, up that high, you can work out how far it is. It's I've got a ruler there, I could measure it, but I don't really want to get out the chair and you know, stumble over there and avoid the tripod. Now, you show me any other detector that can do that. That is amazing. Okay, so we'll go to the big target. And I say that trying to be a bit funny, of course. 3 millimeters long, 0.2 millimeters wide, or in diameter, I should say, because it is a circular cylindrical piece of wire. Those are probably okay, somewhere up there. So you can judge the distance there. Like I say, it's running in normal, and it is full gain. Now, here's the interesting thing with the way this circuit works. I don't know if you can actually see this, and I'll turn it around. If you can see in there, this detector has extensive modifications done to it, and I've put the new semiconductors in it. Notice that I face the camera around, it gets a bit noisier, so I'm not sure. It still could be this wireless microphone. I don't know, I'll put my hand over this bit. Yeah, there's something going on with since I put the camera and wireless audio system on, the noise picks up. I can't do anything about it, and you know, there's also a mixing of noise in the room. But this is running in cancel mode, and I've got it tuned as perfect as I can get it to get rid of the noise. But I'm just saying, I'm running a heap of amplification. And if you're worried about amplification, I'll show you something else. People say, oh, well, you run that much gain, you'll never be able to ground balance it. Well, I've got news for you. Now, I'm in normal mode. If you can see on the detector there, I don't know if you can see. It'll howl like a crazy thing. I'll just move this over a bit. You see a switch is in the middle position. That one there, that's normal, enhance, and whatever the other one, special or something. Anyway, I don't know how special it is. No, it is special mode or sensitive mode. Sensitive extra is a really good mode to use, and also the smooth mode on these. And this is a 4500, by the way. Anyway, we'll spin this back around, and we'll just give it a whack with a hot rock. We'll see what happens. I don't know where it is. We'll see. Yes, okay. You heard the audio on that. It's pretty substantial. So what I'll do, I'll just flick it into fixed and then back into tracking, and we'll go over it. I'll just give it another burst because it is a pretty substantial target. Back into tracking. Now that's normal mode, and that is full gain, right? And if you're not impressed by that, nothing will ever impress you. Try a ring. I mean, like I say, it is in normal mode. Go up where my hand is, somewhere up there. Way up in the air, and like I say, it's in cancel mode. So if I put that into mono or double D in a quiet goldfield environment, that would be an absolutely mind blower for distance on a large target. So anyway, I'll bring this back down again, and just say what do we want to do? Let's try and enhance. I'll just flick it into enhance. Now enhance always is a little bit more chattery, and because I've still got this thing on full gain, it is going to be chattery. And close to the coil. Try this one. And try number 3. I should be going across the coil like that, shouldn't I? Just the way I'm sitting. So going along the winding is not going to do anything. But so you can work out the how the detector is working. But like I say, it will make a bit of noise. And if I turn it down, let's turn the gain down. Okay. You got to remember I've got this thing flat out. Now I've turned, everything else is just factory standard, and I've turned the gain down. Okay. Now it's, like I said, it is 10 times less than factory gain, and it's a big number down. So you could go and, well, I was going to say as a joke, you could probably go and work a corrugated iron sheet with gold on top. Not that like that, you can't really do anything like that. But I'm just saying, if you got really, really bad ground, or you get a really bad dry throat, like I've just got now for talking too much. There we go. That's probably a bit better. But we'll go back, even on low gain or next to negative gain, and we're in enhance. Can I get that little 1? I don't know. I don't think so. It really is pushing a lot to ask. It knows it's there, but you're not going to pull up on that, and ground noise and that would swamp it. But on zero gain or negative gain, negative 10 gain, what about the 2? Could you get it? I don't know if you really want to work the hottest ground in the world on no gain, trying to get little specks like that. That's probably asking a little bit too much again. But you know, on the 3 mil, it's very sensitive towards the front of the coil. It's where the windings converge near the front here on the double D. And along the top of the winding. And the back of the coil. So if you really want to work hot ground with a coil, you know, I wouldn't use anything that big. I would probably go down to using something like a little 10 by 5, 10 by 6, something like that, because like I say, I'm just pushing extremes here. I'm just trying to give an indication of how this works. You know, and I can flick this back into normal mode. Oops, too far. We've gone into normal mode now, and you can, like I say, I've got everything on this detector cranked, and I'm pretty sure you can hear it this time. I'm sitting in front of the speaker. I noticed on the last video it was hard to hear. You know, I got a choice of putting the microphone in front of the speaker, and then you won't be able to hear me talk. There's no way I can really put it halfway because I've got to keep rotating myself around, and yeah, it's just difficult. So I'm trying to stay looking towards the speaker and sort of work a little bit sideways, trying to get the audio levels up. But like I say, that amplifier there is full. I can't go any more on that. It's full. But that's no gain, minus 10 dB gain. I keep saying no gain. Well, I mean it's no gain, but where I've set my amplifier control on the front of the detector. The rest of the stuff is in factory, and that was the normal mode on a 3mm long piece of wire sitting in there. As I say, you can have another look at it sitting there. It's really big target. And you probably remember I was scrubbing that. I nearly sneezed. I just held it off. Like I say, I don't edit my videos. You're going to get all the good with the bad and the bad with the good, and the funny stuff. But remember, I had to actually scrub that on the 5000. Oh, when I had this coil on the 5000, and it just wouldn't hear it, no matter what mode it was. I mean, this is how I had to pick this up with the 5000, right? Standard, factory standard detector. I had to do that, and it was the most slightest whisper of a signal we got back. It was something like this. Yeah, this is things at no gain. So that's it. You know, it's become miles ahead of standard detectors. This is miles ahead. I know it is. We've been prospecting since 1980. It's a lot of years to know detectors. You know, I'm not you know, riding my own boat here or big noting or anything like that, but it's just a fact. It's just a fact. So that is No Ears. That's No Ears. You know, it's a bit messy because this detector has been pulled apart and put back together. I don't know, maybe somewhere between 30 and 50 times. You know, it's had a lot of work done to it. The power supply has been done. I've got 4 loaded preamplifier boards in the detector. I have driver board and variable gain amplifier board. Plus I've got all the new parts underneath this as well. So I'll just flip this off. I don't mean give it the bird, flip it off, but I'm going to flip off the mylar connector, and I'll just lift that up, and you can see that it's written on there too, No Ears, and it's got new components. I haven't done this one, the damping switching MOSFET, even though I should have, but I don't want to run out of these devices because I've had a few detectors come in where everybody wants those put in. They want you know, gain boards, all sorts of things. Now I should point out as well for you people, a lot of guys or girls or whoever do not want the gain control on the front. They, you know, there's some people who've told me that, oh, it's an extra control. I get confused enough anyway. So, and you know, where do you put it? Well, you put that where you bounce the coil up and down the ground or move it side to side, and you just move it from where it's noisy to where the noise just fades off. So it's like normal ground detecting. You can't, if it's really extensively noisy ground, you can back it off more, right? Or you can, on pipe clays or benign grounds or whatever, you crank it right up, whatever. It gives you the maximum performance for the ground type, right, in whatever mode you're in. And like I say, most of those tests I just then was in normal mode, so I wasn't even using enhance. So that picking up the small targets like that was pretty good. That's like I say, to me, that's outstanding. This would be my go-to detector of choice. Now, so that is No Ears. Now, like I say, I can put all these new boards, put the new parts in, and we don't have any control here. You can have your detector, if you don't want it, just say, and what you do then is you use your back gain control. It works fairly similar, but you've got less range because you can use the back end control and the front to get more range. And if you really want to super boost it, you can do like so. And if you want to really dumb it down, for if you're working ridiculous crazy ground, or you got massive electrical storms, or you got over the horizon radar, or massive atmospherics, or whatever's going on, crank both of them down, right? Normally what I do, if I was in a situation like that, I would leave the back gain at factory default. Now, factory default on these detectors, depending on what model it is and when it came out, can be 8, 9, and 12, I think, from memory. And I would then adjust the front gain and just listen to how much pickup there is. And if you get that right, then you turn up the back gain and see, where your pain threshold of noise is. You don't want to be up north around Northern Territory in the middle of the monsoon with all that lightning going on and whatever. But you could actually get rid of that. Okay, this is saying low battery. I just got to close that off. I'm still working, good. I've got about a few seconds of battery left, I think. So that's the game. Anybody who wants anything done to their detectors, you want it, you can put anything in these things. I've been doing it for yonks. So on this particular one here, and what I've got to do behind, and I think I've got another one just came in. I don't know whose that is. I think there's a toll one over there came in just before. So I've got more detectors, and I know David's got some at his place he's going to bring over. So I'm going to be pretty busy doing some detectors. Like I say, I keep trying to get out. I can't. I've got a fellow coming around to pick up the 7000 later on. And I just got that in the other room. I'm charging his batteries, and he's WM12. So if he wants to go out and give it a swing, he can do that, and I'll get some feedback off him. And yeah, that's where we're at. But like I say, with these upgrades, remember too, with my upgrades, I put a 5-year warranty on all my upgrades, right? So if I put anything into the detector, I'll give it a 5-year warranty on what I've done. I'm not going to warranty all standard Minelab parts because that's Minelab stuff. It's not mine, and it's no big deal anyway. If there's been stories out there that if the detector blows up or something, oh, Minelab won't fix it. Well, guess what? Hello, send it back here. I'll fix it. I can fix these detectors. It is not a problem. I've got all components that go in these detectors. I know what they all are. It is not an issue whatsoever. The only thing that I don't have is the microprocessor chip which has been programmed by Minelab. And you know, if you have a look at a microprocessor chip, I'll just grab a scrap board over here. This one come from someone years ago. They had a go at taking the paint off it, but it's ended up here. But on this chip here, that's all, you know, proprietary coded, and you can't get into it. You can't read the code. You can't do anything. It's got 256 legs on it, all fine pitch. You don't really want to take that off and put a new chip on it. You know, I think if you actually said to Minelab, you know, oh, I want a processor, I think they tell you where to go, or they think you got rocks in your head, one or the other. Trying to put that on, you really should have industrial pick and place type machine and industrial oven to put those on. Something you really can't. You can do it. I have done it. I don't want to do it ever again. But all this stuff here, you know, all these chips, there, whatever. Even the transformers, I can even rewind those transformers if need be. There's nothing hard, you know. There's nothing difficult. And the transistors or FETs that were those ones there, you know, that's what I take off and I put the new ones on there. So, and also there's a couple here as well. On this is a, I don't even know what this is. What is it? It's an old 4500, and yeah, it's definitely been stripped down. Not in the best way either. I mean, pretty woeful. But like I say, can fix detectors, not a problem. Yeah, unless it comes off a quad bike at 100 mile an hour like someone did. That was the end of that detector. Fractured the boards. Yeah, so it's quite funny because I gotta say this, right. This is I copped this again today, right, in a message that someone said to me, and they're local. They said to me, I've been watching your videos on the mods, and he says, isn't it funny that there's still people out there who say mods don't work, right? And I just go, oh yeah, okay. So for doing this for over, I don't know, God, what, 25 years? And I've been doing mods for 25 years on people's detectors, and they don't work, right? And yeah, I'm broke, I'm out of business, and I've been sued by everybody because they don't work. Yep, funny that. And the other one I keep hearing too from people that there's some Minelab dealers, right, bad mouth the absolute living hell out of me, right? I know who they are. I keep hearing it. There's one particular place in particular who's very, very vocal. They're very, very lucky I haven't sued them for defamation or slander for what they've been telling people. But you know, when it comes down to it, they are a dealer and they've got a vested interest in selling a new detector. They don't want their customers getting their detectors modified and upgraded. They want you to buy a new one. And, you know, and in my humble opinion, why would you buy a new one when you get your old one? Just get it done up. And it works as, you know, oh, let's say this is debatable. Does it work as good as the newer detectors? And I say this is debatable, right? It's far quieter than a 6000. It'll pick up gold like a 6000 does. It will pick up very, very small gold. See, I've been comparing it with the 6000, but the 6000 doesn't have a big coil on it. And it has a, you know, a purpose-built mono. I don't even know what the windings are, and it could be flat wound too, which is going to work even better on small gold. But do people know that if you have a flat wound coil, you don't go as deep? Did anyone tell you that? Probably not. So a flat wound coil is a compromise between a coil size of the innermost part of the winding and the outermost. So you can actually say, in all reason, as an average, it's the middle of the winding is, you'd call that an average coil size. And, you know, because the windings are closer in, right, it's going to pick up tiny, tiny gold better. Now, if I got a, I'll tell you right now, if I obtained a flat wound coil, and the reason I don't use them, I don't like them. There's I could get into it and give you a big spiel on why I don't like them. I've done tests, I've built them, I've done this, done that, right? But if you understand the physics of how these things work, you might realize that a very large part of the winding is very, very close to the ground, and the ground in a lot of cases is very reactive, right? Now, that could have a very disastrous end result on trying to recover a signal from a deep target. It may just get cancelled out because of the way things work. What I like is the most efficient coil, right? Most efficient design is one that is shaped like that as it goes around. Or you can have square, you know, I can't make a square like that, or pretty close, a square wind, but a round wind is better for deeper gold, right? Flat winds are not. They are not designed for that sort of prospecting. And it does amaze me, a lot of people run around flat wound coils. And I just go, oh yeah, righto. If you have a look at some of my old videos, there's a few of them there where I'm just using standard normal coils, and I get exceptional big target depth. And if there's some there, I think there might be one with had Matt in there, and he was using some type of flat wound coil, and there was a massive drop off on the depth. And you know, I've seen this. I've wound up coils. I got you know, I was making coils for a while. We're going back um, 9 or 10 years ago. Like I've got a huge vacuum former, half as big as my workshop. I can make big coils if I want, and you know, I did. I molded the shells and wound the coils up, and they work. And you know, I haven't got one of my coils. I think I've lent them all out to people, and we haven't got one. Uh, I don't think I've got any. I just, there's none in the. I actually went looking for them the other day. I went out the garage. There's none there. So yep, there's none in here either. So they're all gone. But we did do tests with those coils against other coils with um, a a dealer. I won't mention, just in case it causes problems if they're a particular brand dealer, and I say something, but this is the God's honest truth, that our detectors outperform the others. Our detector coils outperform the other coils at the time, and that was probably going back around 2014, 15. So, you know, if anyone out there who was with us on those, you know, in those years, mucking around with coils, you know who you are. Um, yeah, you know, they were equal width, equal height wound coils, and on those we were not even utilizing carbon or graphite paints as Faraday shielding, or you know, anything like that. We're using different materials, and we had better performance. We had lower noise, we had greater depth, and you know, to this day, you know, maybe I should have gone into making coils, you know, because you know, it would have been the go-to coil place, but you know, now everything's chipped. I doubt any particular company would give me handshake chips to do it. So, you know, prospectors miss out. That's the way I look at things. It's not like I miss out, you know, because I've got a lot of other things to do, but the prospecting community misses out with this. Well, I'll call it locking up of the industry. It stops innovation and experimentation, and I don't like it. And it just narrows down consumer choices, doesn't it? You know, that's what it does. Why do you think I stick with these detectors? There is a reason, because you can do things that you can't do with the newer ones. You can fix the newer ones up a bit. You can do stuff to make them quieter, or just do some changes to the operational capabilities of it to some degree, but not a lot. Um, yeah, you know, if you want to do experiments with coils, what do you do now? You've got to either you know, chop the dongle off and open the detector and solder it on the back of the coil connector so it's always there. And then you can make coils up and start experimenting. You know, that's an easy way to do it, because the dongle's always there. It doesn't even need it, you know, the detector will turn on without a coil on it. Work that one out, rather than just wanting to shut down. But, you know, that can be done. I don't like the idea of making extension leads with the dongle chip in it. As soon as you start running extension leads, that is going to hit the performance a little bit, uh, just due to extra connections, resistive losses, noise through you know, metal to metal contacts, and a little bit of extra cable capacitance as well. You know, stuff you don't want. Like I say, I've been doing this a long time, and I know all the pitfalls. I was just saying what the pitfalls are. Anyway, I hope you enjoyed that. I did. I want to go out and swing this thing and see how I go, because I think it's going to be a thumper of a detector. It's going to be really, I want to run a really big coil on it, you know, like a 30-inch mono. And some places that I know where big gold was found, and I think I could probably get down a little bit more in depth. And it's not just getting down more in depth, it's the signal to noise ratio, even in the from the furthest depth you could get, all the way up close to the ground. Because if you got noisy ground, or um, anything like that, and it's just noise anywhere, you can optimize your detector to get that extra depth even on smaller gold. You know, on some cases, like something the size of an egg that was, you know, at a distance where a normal detector would just detect it on the fringe. Right? I've just, oh, well, this is what I get from Talbot at the test site there. I can get that another 6 inches down. So, you know, hey, what's down there? Where there's one, there's more. And if they're, you know, a slight distance away from each other in depth, well, they're still sitting there, aren't they, waiting for discovery. Um, and someone actually did ask me, I think, a while ago about going out to a spot with a special detector. Um, and yeah, if you see the video, you can contact me. We can go out to that spot of yours, and we'll go over it with a big coil, because that, well, you wouldn't sneeze at something of between 80 and 90 ounces, would you? And that's what it was. So there's a few people who found big gold, but they just don't have the means to get down that deep. So, like I say, you have to have the older detectors. You need really big coils within reason. You know, you're not going to go use a 30-inch coil trying to pick up, you know, 9-volt battery size targets, even though you can, right? You're better off with something around a 20, 25, not getting too big on stuff like that. You start getting a drop off in signal response. You know, you've got to match coils for what you're looking for to a degree. And you know, you've got to match how the detector works for the ground. There's a lot of variables, and if you don't know the variables, you might be out there. You know, I know people who go out there and they're out there going, "Oh, this looks like good ground," and they're swinging over hill wash, and it's just hill wash. It's all the gold's down the bottom in the V of a valley, and they got something like 20 meters of hill wash, and they're detecting on it like they're going to find something. And you're wasting your time. You've got no idea. See, people don't even know where to detect. The easiest way to detect on hills. There's no hill wash there, and you're pretty close to the bedrock. So that's one way of doing it. Anyway, look, enough waffle. I'm going to go and put this back together. I've got to get these other detectors done, or else I'll be getting an ear blast off people. So catch us later.